Greetings, the Astro 30 here yet again, and welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Cheers. Sitting on the desk today, I've got an Amber Series 50B integrated amplifier. It came in a couple of months ago, not working. There's no output. It does power up. Admittedly, there is footage of this I shot a couple of months ago, but I lost it. So I already know ahead of time what one fault is with it. And there is another slight fault, but I'll get into that in just a moment. But first, let's get the lid off, or the casing off, and have a look inside of this beast of an amplifier. Now, this is made in Australia, in Melbourne. And of course you cannot get the service manual for this because it's proprietary. We don't want anybody having our design so they can copy it and make money on the black market and bullshit like that. And it's screaming late 70s, early 80s, the design with this wood grain side panels here. But yeah. Anyway, let's get the casing off and we'll have a look inside of the thing. It's a real shame that I lost the original footage, but I thought I copied the files, but I actually copied a duplicate of the same files I was copying at the same time. And all that ended up doing was me formatting the camera, the SD card, and losing the information. There's also different types of screws in here. There's a machine screw, a PK screw, and stuff like that. And there's a missing screw as a bonus, which is... So there's like 3 different screws in this, which is kind of special. There's also 2 screws at the back here I've got to remove in order to slide the cover off. I believe from memory it slides backwards, or it just lifts straight off. I can't remember. Okay. There's also a screw missing at the back here. What else is here? And there's a bonus, a shorter screw, which is not the same length as the rest. So yeah, there's all different screws in this thing. It feels like it just lifts straight off. There we go. And there's a look inside the beast there. 2 huge filter capacitors. Now they are 21,000 microfarad. Can't really read the voltage. I think they're about 80 volt, something like that. It says positive plus 8 something or other. Anyway, so 21,000 microfarad. There's a relay here, which, okay. Now the thing is, through testing of this has got its own separate headphone amplifier for the headphone socket, and the left channel is quieter than the right, so that's one problem. Second problem, there's no output coming from the output terminals at all when the amplifier is on. And this channel here, which I'm not sure which is which, the output stage is fine, it's not shorted, but the power supply rails between the negative and ground are shorted together. So there's something in this negative circuitry here that's shorted, and we've got evidence of burning on this capacitor. It actually has burnt through the insulation on the other side, and there's a diode underneath that, a power diode. I'm not sure what value it is, probably a 1N5408 or something like that. That's crispy fried, and yeah, almost set fire to this cap. So something catastrophic has happened in this amplifier to cause it to do that. That's probably the worst I have ever seen in a while, actually. Now the reason we probably haven't got any output coming off of this channel is something probably to do with this relay, which is marked AMF, which is actually a bowling ring. Okay. Potter and Brumfield. Well, it looks like a relay. It's got a coil in it. There's a dead short across this fuse holder to ground on this channel, so that is one problem. Plus someone's been in here and messed around because there's RCA sockets missing. The preamp's right output is missing. There's one here which is supposed to be the power amp in. That had a piece of tape over it, actually a cover, so like a sticker, so you couldn't actually use those. So they made it so you couldn't have like the preamp going directly into the power amp. It's probably hardwired that way, and actually did a pretty hack job of it as well. So this is a single circuit board design, and it may look like a complete nightmare to service. Well, it actually is. There's no bottom removable cover, so this board does actually slide out forwards. You have to take the front panel off, all the knobs and the nuts and accessories, unscrew the thing, pull the panel off, and then unbolt the heatsink, which is just 3 screws on the underside that hold it on, and you can actually pull the board out and flip it over to service it, which I have already done. But I want to know where this short is coming from, because the transistors are fine, as far as I can tell. There's 2 transistors here which look like the drivers for the output stage, which are a pair of MJ 15003 and 15003, 15004 to confirm that. I believe these 2 transistors here are drivers, so conveniently they're marked base collector emitter. I've already tested the output pair, they're not shorted, so we know that those transistors should be fine. So that's, I don't know what that is. Well, it's not that way around, so it'd be this way around. Good junction. Saying 0.1 of a volt, which is odd, but collector to emitter, 1.3, 1.4 rising, nothing there. So this is the other way around. Good junction, good junction. So that one there to there is a little bit suspect. It's 0.1, it should be 0.6. So luckily there's another one over this side the same. So I can test this one and I get exactly the same readings. So it's not that. And I'm going to assume for all intents and purposes that this channel works, only because it didn't blow the fuses. So this is the 1503. That's really low voltage. So is that one. There must be another component across it, more than likely. Okay, so there to there. It's a good junction. Seems okay. Yep. This one's a bit harder to test. It's the other way around. Right, okay. Do it right to the case instead. That's the emitter, if I can get to it. Yeah, it's showing a very low voltage, but that could be by design, like there's something across those pins. If I compare it to the other channel, it's doing exactly the same thing. Okay, so that's not an issue. Now, there is also an op amp here, which is an LM391N, which I believe is a quad op amp. So that'll be responsible for, well, voltage amplification and input, I assume. Okay, so if I go and look for a ground, which is, well, there's a ground here, I believe. Yep. And go to the negative rail of the power amp. There is about 30 ohms there, but dead short on that side, and I believe that's the amplifier side. So let me find a screwdriver wherever that's buggered off to. I need a small one and I don't know where it is. It seems to have gone. I'll use this big ass one then. I'll do. Just to pop out this blown fuse out the way. And that must be the input side. And that would be the amplifier side. It's reading 30 ohms, which is, yeah, okay. But it shouldn't be that low for a start. Because if I measure the good channel, well, 300 on ohm and rising. So, yeah, there's something dead short on that amplifier. It's now like at 600 ohms and rising. That's only just charging the filter caps here. So yeah, there's something here which is shorted. What I might do is I might pop that integrated circuit out because it's socketed, which is nice. Once I find what I did with my little screwdriver, because I had that just a few moments ago when I was doing something else, and it seems to have gone. I don't know where. Oh, there it is. So I will just pop this IC out and see if it's not the IC causing the issue. Well, that didn't exactly go the way I wanted it to. There we go. According to that, it goes that way around, the opposite direction to that way. But it doesn't look like this socket is keyed. Yeah, it's not keyed. So you can easily put that integrated circuit in around the wrong way. That's nice. Okay. Let's see. It's this side. Right, the short's still there, so it has nothing to do with that integrated circuit. So I'm going to pop him back in the way it came out. It'd be nice if there was service data on this so I could actually get a schematic so I could actually see how the hell this thing worked and how it was wired. So I believe I've got all the pins in and it's not like shooting pins out where it shouldn't be. Yeah, so it's got a short. Now I know it's not these capacitors or this capacitor and that diode because these go between ground and the negative rail. I've lifted them out of circuit already, and as I say, I've already lost the footage for that, which is unfortunate. But it's not that. So without a schematic diagram, it makes it awfully difficult to pinpoint where the fault is. What I do want to know is why is there no output on the right hand channel? Because I reckon this relay has got something to do with it. And it's not engaging. So what I want to do is I want to see if there's any DC actually on this channel's output. Because it may have a DC protector circuit in here, but it doesn't look like it does. It just looks like two transistors driving the relay. But I want to see if there's actually just one working channel in this. Alright, I've got the amplifier hooked up to the dim bulb. I've got the positive probe of my multimeter hooked to one emitter of the transistor output stage and the other end of the meter. Granted, in voltage DC mode, so I'm basically bypassing this relay. Turn the dim bulb on and turn the power on. Yeah, well, that could be an issue. Yeah, it's got DC on the output. Oh, it may be common collector output. So if I touch the collector, that's a bit better. The emitter is the supply rail, I forgot. I've already been through this for about an hour beforehand. A couple of months ago, I've just forgotten. There we go. We've got 62 millivolts. Okay, that does seem probably a little high. But if I measure across one of these posts, I've got 15 millivolt. Nothing on that one. So that must be the output of the other amplifier that's working. And that's interesting. So it does look like this channel is working, but I still have no audio output. Unless the fuse is blown, of course. So the right comes out of here. I'm only seeing 15 millivolts there to the fuse. After the fuse we've got nothing. And before the fuse we've got, that's probably the wrong one, 15 there, 15 there. So that should be our output point. Got a speaker hooked up to the working channel. There was a bit of a pop there. And I do hear a hiss coming out the speaker. So I need to grab an input lead. And I know that that's the right channel now. So the one that's blown is the left. So I need to plug into an input somewhere. Tape in. Ow, that was my head. Taping right. And that's supposed to be the volume, but the knob's missing. And the center one's balance. Alright, so tape. Okay, nothing there. Nothing coming from the phono output. So tape 1. So I've got nothing coming in there. Connect to the phono input. There's nothing coming through. Not to the speaker anyway, so I don't know what that relay's purpose is, but it's not for the speaker outputs because they're hardwired over here. So this must be to disconnect the preamp from the input to the power amps. Well, I haven't found the source of the short yet, but I was just tracing this other problem with the preamp relay, which doesn't actually affect the headphone socket that comes before it. I did lift this resistor out of circuit, which actually gives charge current to this capacitor sitting here, which makes the 2 PMP transistors which drive the relay in Darlington configuration turn on after a short delay. And when I measure across this resistor, I had to take it out of circuit so I could get a better reading. It appears to be open because it's not measuring anything. It's just ranging. So that could be a problem for a start. So that's a green, yellow, white, orange. So that should be a 549K. So I wouldn't have a 549K, but that's what it should be measuring at, and it's not measuring as anything. So that resistor needs to come out, and I need to temporarily put another one in its place. Right, so 560K is the closest I've got, and I've just tacked it in there at its full length because I have to pull the board out to do it properly, but I'll just leave it tacked in like that for now. See if that makes a difference. Well, no, it did not. So we still have no voltage. Oh shit. Well, that's in ohms for a start. We've got minus 21 volt there now. The destruction that's gone on in this amplifier here is just kind of ridiculous. And that shouldn't be doing that. Like, it should automatically start charging and disappearing. It's like, there it goes now. It's like those capacitors are done. Yeah. So what I might do is I might temporarily remove them out of circuit. That is, I'll lift one lead out so that I can isolate that from the thing. I'm going to find what I did with my pliers. I've already done this once because I think I was chasing a similar problem the last time. So that one's out. That one's out. It's double-sided board, so that makes it a little bit easier to desolder things. So those two capacitors are isolated from the circuit now. So I should have no, but I do. Because that's on the negative side. And there it goes, it starts buggering off. So what else is in this circuit that could be causing that? I think there might be a smaller capacitor, like 100 nanofarad or something, across the fuse holder, or across the negative rail, which there is. And that goes to ground, but there's 30 ohms there, so something else here in the circuit is shorted, and I don't know what. The diode itself, which is here, and I'll bring the camera in just so you can see the destruction to that capacitor. Look at how it's melted the insulation on that. And there's a diode there which is all crispy fried as well. Yeah, this thing took a whack. I mean, I can't even see the cathode band anymore. It's like totally destroyed. This capacitor looks like it's got a hole melted in it. So yeah, that's not good either. The one next to it doesn't look that much better. I might actually attempt to remove those out of circuit as well, just to isolate that. Well, that capacitor is just completely broken to pieces. It's destroyed itself. So I wonder if the short's still there. So go from fuse side, amp side to ground. It doesn't appear to be a short to ground anymore. Not as far as I can tell. That's fine. There's no short to ground anymore. I reckon that capacitor was shorted. Well, it was burnt anyway. The other one's not much better. I'm not even sure what it is. But now that I've got that completely open, the short has buggered off. So yeah, that's good. I need to find out what that capacitor value was. It's a 400 volt. 822. I think that's what it says. According to the other working channel. Oh, it's a 0.022 microfarad at 400 volt. So yeah, that capacitor is done. So that's a problem. So I might just pop these capacitors that I took out back in circuit. Right, the capacitors are back in, so should be safe to power up. Still getting the same amount of current draw, but we do have 2 blown fuses. I might have a couple of 4 amp fuses and I might stick in to replace these 2 and see if we get shitloads of current on the dim bulb. Okay, fuses are in. No, we don't. Okay, interestingly that appears to be okay. So let me just measure the output voltage on that channel. Well, there's nothing on that side. Got -3.7, which is not right. Right at the left. Okay, on the collectors. -3.7, so there's something else still wrong here. But at least the short is gone. So that's good. So I was curious to see what the left-hand channel's output was doing. Nothing. It's just random noise. So yeah, okay. So whether that capacitor needs to be in circuit to function properly, I don't know, but current draw is not excessive. So there's no short circuit there. The relay still refuses to come on for whatever reason. Yeah, so basically what needs to be replaced is the diode, these 2 capacitors, and the busted capacitor that's now in 2 pieces. And see if that improves matters much. But yeah, we've got nothing unusual on the output except we've got, like, you know, -3 volt DC there. So if I measure at the output post, yeah, we've got -3.7 volt DC there, which is enough to destroy a speaker. So yeah, I wouldn't connect up a speaker or a load at this point, because the amplifier is obviously still experiencing a problem. Not sure what at this stage, but it is progress. I've got rid of the short, so that's good. So yeah, crispy fried capacitor obviously had burnt and gone short circuit, and there's no short circuit there now. Plus these are the wrong fuses. They should be fast blow, not slow blow. Yeah, but anyway, I need to find out what that diode is too. I mean, even though the diode is conducting and it appears to be functioning fine, considering that it's like burnt and crispy fried, I don't know whether it was because the capacitor decided to go up in smoke or the diode itself started to go up in smoke. They just supply our discharge diodes, clamping diodes basically, to help the filter caps here discharge quicker. But yeah, from what I could see, voltage wise, if I now measure across each emitter, if I can without shorting things. Now keep in mind that the dim bulb will be limiting the current. One emitter here, we've got -25 volt, and I'm not sure where the other emitter is because I can't see it. is somewhere. But I can actually just measure across the supply rails. So the negative supply rail is minus 25 volt and the positive supply rail is positive minus 25 volt. That's the same fuse, that's why. Positive 25 volt. There we go. When I meant the same fuse, I mean it's on the same line. So it's only running at 25 volt plus minus 50 volt DC. So everything is okay there. But what's concerning is that DC offset. That's going to be harder to find as to what's going on there. But I probably should replace all the 0.22 microfarad capacitors in this circuit, because that one's also crispy, because it was right next to the one that fried. The other two over this side are fine. But as to what these diodes are, I don't know. So there is hope for this hunk of junk yet. I'm going to call it a hunk of junk, but yeah, at least now I've got rid of the short, but I still haven't fixed why this relay is not coming on. I haven't even addressed the headphone amplifier section yet. So this is going to be one that I'll have to investigate at a later date. But the short was my main concern. For the DC offset, I'd have to go through the entire circuit here and check all resistors and other components, make sure nothing's open, which it could very well be. Albeit the two sets of transistors here test fine, so that's good. There's nothing wrong with any of them. The op amp I reckon runs on a plus minus 16 volt supply, because there's a LM317T and a 337T over this side, and the outputs give us around about 16 plus minus volts. So that'll be running the op amp that's just out of frame here, and all the other op amps in the circuit. So yeah, that'll be something I have to do, is go through, check all the resistors, make sure they're not open. And once I've got that and the correct fuses here, yeah, it should be easy to fault find after that. So what I'm going to do now as a last thing to end this video is, apart from removing these fuses now, because, well, I proved that the amplifier will function without drawing lots of current, because the first time I put a fuse in there, or bridged it, yeah, the dim bulb glowed brightly, so it was drawing too much current. Well, it would do, because there was a short on the negative rail, which has now gone, aka that capacitor that's just like completely shit itself. There's a good look at the carnage there. That's all that's left of that capacitor. Yeah, cool. What I was going to say is, the last thing I want to do is try and find out where the input of the working channel is and see if we can get some sound out of it. Oh, not that kind of sound. Which is going to prove a little bit challenging, so everything's still hooked up, so is the speaker. Is I'd have to probe around and see where the input comes in, but sounds like that resistor there. I'm not sure if that's the exact right place to put the input, but I can hear that amplifier is functioning, so I don't even need to put sound through it to test that point. Don't know. Can't get any audio through that way from the relay, but I don't know how this relay works. But yeah, there's definitely signal to there, so that's fine, but I can't figure out where it comes from the relay, but that's really irrelevant at this point. So basically what I'm going to do is I'm going to leave this video here, because I did want to actually look at it again because I lost the original footage, as I said in the beginning. And this is going to be fun to edit. I'll have to take the front panel off to solder in this resistor that's just hanging up in the breeze properly. But I'll do that when I go to rebuild this power amp section. So it'll be in another video basically, because I just wanted to tidy things up and get to a certain stage of fault finding this thing, because I was about ready to give up on it, to be honest, the first time. Yeah, so I'm going to have to get a bunch of 470 microfarad 50 volt axial lead capacitors to replace these two burnt things. And yeah, probably pull out one of the good diodes just to read the numbers of it so I can order the correct diode. Or find the correct diode. If I can get it in J-card, great. So this does actually scream late 70s, early 80s with all these axial capacitors in here. And really bad choice of capacitors. Benick. Never heard of them. So yeah, anyway, this is the Astro 30 saying if you enjoyed this video, please go down below, like, comment and subscribe if you haven't done so already. And this is the Astro 30 saying, as always, see ya, have a great day. This will be revisited once I actually, you know, find out what parts I need for it. But I got rid of the shorts. That's the main thing. So hope for it yet. Alright, thanks a lot. See ya.